Okay, I'm thinking about my orchard now. A gardener wants to buy 2 fruit trees. He likes 3 of them. He likes the cherry, the orange, and the peach. How many ways can he select 2 out of the 3 different trees? How many different ways can he arrange them when he selects 2 out of the 3 trees? Well, and list his possible choices. Okay, so to answer this, we want to use the formula for n choose r. It's called a permutation formula. N choose r equals n factorial over n minus r parenthesis factorial times r factorial. Okay, so what that says is if I have n items, how many ways can I choose r of those items? How many different arrangements? How many different ways? Okay, so we're going to have to choose n and choose r. How many items? It's n choose r, so it's a total pool of n items, and we're going to select r of them. So what is n going to equal? Well, in this case, there are 3 possible choices here, 3 different trees, orange, cherry, peach. Okay, so n is equal to 3, and r is how many you're going to choose. Well, this dude's going to choose 2 of those fruit trees. So r is equal to 2. n is 3, r is 2. That means our calculation is 3 choose 2. Now, it kind of looks like a fraction, but there's no bar in between it, so don't put a bar. It's the permutation formula, n choose r. So it's 3 choose 2. Now use the formula, n factorial on the top, so it's 3 factorial on the top, over 3, that's n minus r factorial, so it's 3 minus 2 parenthesis factorial times 2 factorial. Simplify the parenthesis, we'll get 3 factorial over 1 factorial times 2 factorial. Okay, now let's use our trick for simplifying this. Take that 3 factorial upstairs and just factor it down to something, something, something times 2 factorial and stop. Then you can cancel the 2 factorial on the top and bottom. 3 times 2 factorial, got to stop there. That's as far as you can get. And get your 2 factorial over 1 times 2 factorial. I changed 1 factorial to just 1 because that's what it's equal to. And now we're able to cancel the common factorial factor of 2 factorial, and it leaves 3 over 1, which is 3. That means there are 3 ways for him to select 2 trees out of the choice of 3 different trees. Now we're going to list the different possible choices or arrangements. Well, he could have chose the cherry and the orange tree. That would have been one possible choice. Or he could have picked the cherry and the peach tree. Or the other possibility, he could have gotten the orange and the peach tree. But those are the only possible pairs that you can arrange out of those 3 sets of that set of 3 trees. So there are 1, 2, 3 choices of how he could have chosen those trees. Okay, now you try. You're given a drawer of 11 single socks. And just to make it interesting, let's say they're all different colors: purple, pink, orange, checkered, black and white. How many ways can you choose? A set of 3, 1 for one foot, 1 for the other foot, the other for your hand. A set of 3 out of the total 11 socks. Okay, so we're going to do n choose r. We're choosing 3 of them out of 11. So n choose r formula equals n factorial over parenthesis n minus r factorial times r factorial. Okay, what is n? That's the pool. That's the whole quantity of things we have to choose from. So n is 11, and what is r? That's what we're choosing. We're choosing r of them. We're choosing 3 of them. Okay, pause the video, answer the question, simplify it, come back, start the video, see if your answer agrees. So we have n is 11, choose 3, that's r, is 11 factorial over parenthesis 11 minus 3 factorial times 3 factorial. That's equal to 11 factorial over 8 factorial times 3 factorial. Okay, now simplify using the trick. We're going to take the 11 factorial, bust it down till we get to 8 factorial. 11 times 10 times 9 times 8, stop, factorial, over 8 factorial times 3 factorial. Now we cancel the 8 factorials on the top and bottom. That leaves 11 times 10 times 9 over 3 factorial, which is 3 times 2 times 1. Now cancel common factors on the top and bottom, like a regular fraction. And we get 11 times 5 times 3, which is 55 times 3, 165 ways to choose 11 socks from a drawer, 3 socks from a drawer of 11 different socks.